Okay, for the Algebra EOC, you're given this reference sheet and it looks like this. Now this is a useful tool, but it's only as useful as the information that is on it. Right? And there's a bunch of like conversion factors up here, which in my opinion is a bunch of wasted space. But if you get to a word problem where you have to do some railroad tracking and convert, this is useful if it doesn't give it to you in the questions. Right? Also over here are your different forms of your different functions that we've gone over, and then simple interest and final and compound interest equations as well, which are just souped up ways to say linear and exponential. Right, so in your first like 10 or 20 minutes of your EOC, it is helpful to brain dump everything you know on this. It warms up your brain and it provides you a more effective tool to use during the EOC. So I'm going to walk through how to do that like step by step, kind of deciphering the things that are on here. So let's go ahead and get started with that. Okay, so here I'm going to look at the three formulas, right? And once you sit down, the first thing you should do is identify A, B, and C, and all of those are your y-intercepts of these different functions. Okay, so A, B, and C is your y-intercept. Now go to your linear equations, right? This is point slope form. This is slope intercept form. This is standard form. This is point slope form, right? So slope intercept form, it gives you the slope and the y-intercept. So let's break down slope a little bit. Slope is the change in y over the change in x of a linear equation, right? Remember, notice you only see m in the linear equation, where slope is a change in y over change in x. And remember that the change in is a final minus an initial, right? So as you read left to right, as you lead on a coordinate plane, left to right, okay, your x value, your final is going to be the most right, and your initial is going to be the most left. Okay, so that's your change in y over change in x. So put all this together, you get that slope equals your change in y over change in x, which is your final y minus your final y on the numerator, or your initial y on the numerator, and then your final x minus your initial x on the denominator, right? So that way you can figure out slopes with tables or a line on a graph or something like that, okay? And then it gives you the point slope form, okay? Point slope form has the slope, but it also has these points on here, where these points are the points from an x and y coordinate on the coordinate plane. Recognize that the negative sign makes them opposite. Like these negative signs right here make them opposite of what they are in the equation. So for instance, if that was -1 and 3, your y value would be 1 and your x value would be -3. Okay, so you have to flop the sign. So when you're writing this equation out, write it out with the minus signs and all the different variables, but leave the y's blank and then drop in your numbers, and it'll automatically change the sign for you. Okay, so that's, and then your slope, your standard form, it's not really useful, but you can convert from here to either one of these using algebraic rules. All right, over here is your forms of your quadratic equation. And one thing I want you to know, this is your vertex form. It's your most useful form, in my opinion, is right there. Your most useful form. All right, so here you can take this equation and modify it a little bit to get your last form of, or your last function that doesn't give you any absolute value functions, right? So your absolute value function is almost identical to this, except you write a And then instead of parentheses, you write absolute value bars, and it's going to be x minus h in there. And then you don't write the square, there's no square, and then it's plus k. And now you have an absolute value function. Right, and recognizing here that your h and your k values for both of these, h is your x of your vertex, and k is the y of your vertex. Also, again, recognize that it's negative h, right? H is so x is negative, so a change in these, if it changes to the left, which is normally negative, you have to add. If it's changed to the right, you have to subtract for your h and your k. So that's something that you could probably write over here. So for changes, for translations, right? When you're shifting graphs, if you're going left and right, that's your x value. It's going to be opposite. It's positive or negative, right? For your change in y's, right? This is your y value. That's intuitive. Up is positive, y is negative, and that's because this k value is positive in here, right? And pretty similar in here. Shifting linear equations, shifting horizontally left and right is a little bit beyond the scope of just dropping stuff into here. So you need to go into a little bit more than that. But for this one, it's pretty easy to shift these up and down. Okay, and then over here you have this P and this Q, and this represents your x-intercepts. Now again, x's are negative, right? So x's are opposite, right? Negative, opposite. Okay, whenever you see a negative sign in some of these equations, it's opposite, right? So if you had like a 3 here and a negative 3 here, right, your x-intercepts would be 1 or it would be -1 and 3, right? -1 and 3. So okay, so this is a standard form, and this is a factored form. Okay, and over here we have f sub x equals, this is exponential, right? A is your y-intercept. Ooh, I almost forgot to tell you about this one over here. So a in these things, a, okay, your a, if it's positive, is going to be concave up, whether it's a parabola or absolute values. If it's negative, it's going to be concave down. Okay, another helpful hint. All right, so now actually moving on to exponential functions, right? Remember that b and 1 plus or minus r are interchangeable, right? So b equals 1 plus or minus r. When b is greater than 1, r must be positive, and it is a growth. When b is less than 1 but greater than 0, right? Greater than 0, so between 0 and 1, right? R must be negative, and it's a decay, right? So there's that. So you can fill those out. So this is going to give you a rate. Sometimes it's in a percentage, right? Just read the words and see if the function goes up or down, right? This is a growth. This is a decay over your x. Okay, this is a growth. This is a decay. Whoops. This is a decay, right? But it's negative. Okay, it approaches the asymptote. All right. Over here, I have a linear simple interest function, and then I have a exponential simple interest function. All right, and in both of these cases, the t must be in years. okay? The rate is going to be in percentage. You divide it by 100 to a decimal. Okay, that's your percentage. Okay, and then for this n value that changes both the exponent and the denominator of your rate, which is just the r value up here, right? There's different scenarios. If it's annually compounded, it's 1, n, and then compounded. So how often is compounded? If it's annually, it's 1. If it's monthly, it's 12. If it's quarterly, it's 4. And if it is daily, it's 365. All right, and then the principal is your starting point. Over here, rearranging this or having different forms of this linear equation is very helpful to have, right? So the amount of money you have when it's all said and done is equal to the principal plus the interest that it made, right? This interest that it made, if I were to rearrange this equation and distribute this into here, A would be equal to P plus PRT. This PRT value is the interest. All right, so I equals PRT. Okay, so if you wanted to rearrange this equation, if it said, if it says that, hey, I started with this much money, right? I ended with this much money, but I started with this much money. That's going to be equal to the interest. That's just rearranging this. And then, like, what's the rate, right, over this much time? You can solve. You're now going to have what your I is, but now you can rearrange this equation and solve for R. So R equals I divided by PT, because I just got to divide both sides by P and T. Okay, so that is the front of that, and that is a little bit more helpful, right? On the back, I advise that you give yourself a simple perfect square list. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, up to 15 is usually pretty satisfactory, right? So this is n. If we square n, it's going to be something else. This is not the n that's in the compound interest equation. This is just a number. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 144, 13 squared, 169, 196, and then 225. Okay, so that is your perfect square list. And you do this because when you have a square of something real big, say it's 288, right? You know that this is not a prime number because it's even, right? So you can break this down some more. So instead of like starting at 2 and breaking it down and just divide it by 2 until you see like the same number twice inside your radical, you can start dividing this thing by your perfect squares, right? So if I do, and then if it yields a perfect square, take it out. So 288, let's like divide by like 64. That doesn't work. It's not an answer. Let's divide by 49. That doesn't work. That's a fraction. Let's divide by 36. Oh, look at that. That is a perfect square, right? So I can do square root of 8 times 36 is 288. I can bring out that 6, right? Now it's 6 square root of 8. But now it's a little easier. Now I can just have to break down 8, right? So I can be like, okay, 8 is 2 times 4. 2 times 4, and right there is a perfect square. I can bring that out as a 2, right? So, and I can say, all right, 2 times 6 is 12 times the square root of 2, right? So if I broke, so now this is a lot easier to do algebra with, like maybe cancel out the square root of 2 if it's a numerator or denominator and you have it in both, right? But if I can check this and be like 288 square rooted is that number, right? If I do the square root of 2 and then multiply it by 12, it's the same number, right? 16.97, 288 square root, 16.97 and some stuff, right? So these are equivalents, okay? That being said, you can do your table for your exponents, exponential rules, where you have x to the 0th equals 1, x to the 1st equals x, and you know if you take x times x to the a times x to the b, you got to add the exponents as multiple, so it's going to be x times the a plus b, and then if I take x to the a divided by x to the b, this is going to be x to the a minus b, right? So there's those ones. Then I have something like x to the a raised to the b. This is multiplication. This is x times a b. And then I can start with the little goofier ones, where if I have x to the negative a, it equals 1 over x to the a, right? And if a is 1, it's pretty easy. And then and these go both ways, right? So that pretty much sums up these ones. Then you have your reflection table, right? Start with your parabolas and your, I'll do it like that, sure. So that is for a quadratic or an absolute value, right? This is for a linear, and this is for an exponential, right? Just real quick, you already have those values right here, so you don't need to remember that. Then you say a reflection, reflect across x and the y-axis, right? So when this, and then you can just kind of be like, all right, think of some mnemonic. I think we went with like, I don't know, aardvarks, kill many bugs at homes, was it homes made recently? Yeah, right. So yeah, aardvarks kill many bugs at homes made recently, or something like that. I don't know, whatever you think. Now this will tell you, like, if it's one of these types of functions, you reflect it across, and you reflect it across x, you need to change the sign of the a and the sign of the k. If it reflects across the y, you only need to you only need to go across the h. Okay, and then finally, for dilations of equations, if f of x changes into f times a of x, meaning that only x changed, right? This is a horizontal dilation. If change in x and a change in whatever the constant is, whether it's c or whatever, or b, if both of those change, that is a f of x, an f of x that went to a times f of x, right? Meaning that the whole function got multiplied by it. This is a vertical. So this is a both x and c changed. So first determine if it's horizontal or vertical, and then just know that if it's a vertical or horizontal.
Good morning, can I have your attention? 10. Thank you.
And if a gets closer to 0, or if your change in your x value got closer to 0, For a vertical, it's a shrink, and for a horizontal, it's a stretch. And then if A departed from 0, it's opposite. It's a stretch and a shrink. Okay, hopefully that helped out, and we'll good luck on your EOC.